Hello, my name is Hyung-Kyun Yu, roll number 23035010361. The recording date of this presentation is February 16th, 2026. I'm a student in the Bachelor of Science Honors, Data Science and Artificial Intelligence program at the IIT Guwahati, and I belong to Cohort 1. I'm originally from South Korea, and this project reflects my applied research conducted in an organizational people analytics environment. This video is submitted as my trimester 7 project presentation, completed as part of BA 377, Internship 1, Term Project 1. The title of my research is an AI agent-based workforce profiling and dynamic survey design framework for people analytics. This work sits at the intersection of AI agents, full stack system engineering, people analytics, and workforce feature modeling. In this video, I'll walk through research background, problem formulation, system methodology, technical architecture, experimental evaluation, key findings and future directions. Okay, so research background and motivation. In recent years, organizations have increasingly adopted people analytics, also referred to as people science, to support workforce planning, talent allocation, and organizational strategy. A fundamental requirement in such systems is the ability to represent employees as feature vectors, structured descriptions of the people's skills, technical competencies, task responsibilities, domain expertise. However, in real organizational environments, employee information is typically structured using coarse occupational classification frameworks. For example, in South Korea, many organizations adopt the National Competency Standards, or NCS. While useful for standardized reporting, such frameworks lack the resolution required for modern workforce modeling. They cannot distinguish task level competencies such as front end versus backend engineering, infrastructure versus application development, data engineering versus data science. As a result, analytics systems built on such classifications struggle to support internal mobility modeling, skill based workforce planning, and capability forecasting. To overcome this limitation, organizations must collect fine grained workforce feature data directly from employees, typically through structured surveys. However, designing such surveys presents major operational challenges. Survey schemas evolve continuously through leadership interviews, HR stakeholder discussions, domain expert validation. Traditional tools such as MS Forms or Google Forms are not designed for complex conditional logic, version control, full stack deployment, rapid redesign cycles. This gap led to my core research question addressed in this project. How can we design a scalable, rapidly evolving survey system capable of collecting high dimensional workforce features without heavy software development overhead? Okay, so let's move on to my research objectives. My project defined 5 primary objectives. First, to analyze the limitations of existing occupational classification frameworks and survey engineering tools. Second, to construct a fine grained workforce feature taxonomy through structured expert interviews. Third, to implement a full stack interactive survey system capable of collecting large scale workforce feature vectors. Fourth, to develop an AI agent driven development workflow, translating natural language specifications into executable system modifications. And fifth, to evaluate the effectiveness of this framework in reducing development iteration time and coordination overhead. Okay, so what is my system methodology and workflow? The proposed system follows an end to end workflow from feature discovery to structured workforce data collection. Step 1, feature discovery. Structured interviews were conducted with organizational leaders and domain experts. These interviews identify task level competencies not represented in conventional classification frameworks. From this process, an initial workforce feature taxonomy was constructed. Step 2, survey schema design. The taxonomy was translated into survey structures including question groups, response formats, conditional logic, validation constraints. This schema defined how workforce features would be collected. Step 3, AI agent driven development. A key innovation of the project is the integration of an AI coding agent, Cursor AI, into the survey engineering workflow. Instead of manually editing code, natural language instructions describing survey modifications were provided to the agent. These instructions were translated into executable changes affecting front-end components, backend logic, and database interactions. Step 4, version control and deployment. All generated code modifications were committed to GitHub, version controlled, automatically deployed to a cloud runtime environment. This created a continuous AI assisted development loop. Step 5, data collection. Employees access the deploy system through a web interface. After authentication, they submitted survey responses. Each response was stored as a structured workforce feature vector. Step 6, iterative refinement. Feedback from HR specialists and leadership interviews was continuously incorporated through further AI assisted system modifications. This enabled ongoing evolution of the survey system. Okay, so what was my technical architecture? The system follows a full stack architecture, front end, implemented using Streamlit, providing authentication interfaces, survey input modules, administrative dashboards. Custom layouts were rendered through HTML and CSS integration. What about the backend? Built-in Supabase, providing PostgreSQL data storage, user authentication, and row-level security policies. Survey responses were stored in relational schemas with flexible JSON-B feature fills. Let me explain my deployment environment. The system stack includes Python application logic, Git-based version control, automated cloud deployment. This architecture ensures reproducibility and scalability. Okay, next, let me explain my experimental evaluation. An empirical comparison was conducted between conventional survey engineering workflows and AI agent driven workflows. It took place within an organizational deployment involving approximately 1,000 employees. Survey revision cycles were measured across 12 sessions with outliers removed. So, what were my results? The conventional workflow, the average revision time is 287 minutes. But my AI agent workflow, the average revision time is 17.5 minutes. This corresponds to 83.9% reduction in revision time and 16.4x speed improvement. What about the cost implication? The traditional development would require two amendments, estimated cost of 26 million Korean won, and approximately 17,900 US. My AI agent workflow in my project eliminated this development cost. The findings suggest that AI agents can function as an interface layer between domain experts and executable systems. Key benefits include reduced coordination overhead, accelerated iteration cycles, and lowered engineering dependency. However, AI generated code still requires validation, testing, and governance oversight. Okay, so what is the conclusion and future work of my project? The study introduced an AI agent based framework for workforce feature profiling, dynamic survey engineering, and rapid full stack system evolution. The system reduced survey revision time by approximately 94%, while eliminating major development costs. Future research will extend this framework toward internal mobility modeling, HR development training optimization, and workforce capability forecasting. Large scale deployment will continue across subsequent trimesters. Just to add, the source code repository is publicly available. So let me give you a whole summary of my project. The project focuses on designing and implementing an AI agent based workforce profiling and dynamic survey engineering system in the domain of people analytics, where what is often referred to as people science and HR data science. The research was conducted during my trimester 7 academic period while I was working as principal people analyst in the human resources division at Visang Education in South Korea. Therefore, the project reflects not only an academic exercise, but also a real organizational deployment carried out in an applied industry environment. The core motivation of the research originates from a structural limitation in how organizations represent workforce data. Most companies still rely on coarse occupational classification systems, such as the National Competencies Standards framework in South Korea, which categorize employees into broad job families. While these systems are useful for standardized reporting, they lack the resolution required for modern workforce analytics. They cannot sufficiently capture fine grained task level competence, such as differentiating between front end and back end engineering or infrastructure and application development roles. To overcome this limitation, organizations must collect high dimensional workforce feature data directly from employees, typically through structure surveys. However, designing such surveys is inherently complex. Survey schemas continuously evolve through leadership interviews, HR stakeholder discussions, and domain expert validation. Traditional survey tools are not designed to support complex conditional logic, version control, rapid redesign, or scalable deployment. To address this challenge, I developed a full stack interactive survey system supported by an AI agent driven development workflow. The system begins with feature discovery through structured interviews with organizational leaders. These insights are translated into a workforce feature taxonomy, which is then converted into survey schemas, defining question logic, validation structures, and response formats. Key innovation in this project is the integration of an AI coding agent, Cursor AI, into the survey engineering process. Instead of manually editing application code, natural language modification requests are provided to the agent. The AI translates these instructions into executable code changes, affecting front end interfaces, backend queries, and database schemas. These modifications are version controlled via GitHub and automatically deployed to a cloud runtime environment, enabling continuous system iteration. Technical architecture consists of a Streamlit based frontend, a supervised PostgreSQL backend with row level security policies, and a cloud deployment pipeline integrated through Git version control. To evaluate effectiveness, I conducted an empirical comparison between conventional survey deployment workflows and the proposed AI agent driven workflow within the operational development at Visang Education. The evaluation includes multiple survey revision cycles targeting approximately 1,000 employees. The results show that the AI agent workflow reduced average survey revision time from 287 minutes to 17.5 minutes, representing a 93.9% reduction and a 16.4 times acceleration in development speed. In addition, the approach eliminated substantial engineering costs typically required for full stack system development. In summary, this project demonstrates that AI agents can function as an interface layer between domain experts and executable system implementations. By enabling natural language driven system modifications, the framework significantly reduces development friction, accelerates iteration cycles, and supports scalable workforce feature engineering in people analytics environments. Future research will extend this system toward downstream applications such as internal mobility modeling, HR development training optimization, and workforce capability forecasting. My prior industry experience at Coupang and Starbucks Coffee Korea will be further integrated into these expanded research phases during trimester 8. So overall, this project of trimester 7 establishes a foundational infrastructure for AI agent mediated workforce data collection and dynamic survey engineering in real organizational settings. Thank you for listening.